In this video, we're going to talk about four molecular properties that are intrinsically connected, and these four properties are the bond order, the bond strength, the bond length, and the frequency of vibration. And to start this discussion, we will start with an experimental observation. If you remember from infrared spectroscopy, the infrared spectroscopy tells you that every time there is a peak in your infrared spectroscopy, it relates to the vibration of specific bonds. And in this case, experimentally, we know that the peak for oxygen neutral, it has a frequency of vibration, I should say maybe more of a wave number of vibration of around 1600. For oxygen 2 negative, so once you add one electron, it is 1200. And if you add yet another electron to the molecule, this frequency of vibration, or the wave number of vibration, it's halved again, so it's 600. So let's try to understand and explain why this trend happens. First of all, if you remember from our previous slide, there was, here you go, this is the orbital scheme for oxygen, and for oxygen you had to place 12 electrons. That's 10, and this is 12. Okay, if you calculate the bond order for this, for oxygen neutral, this will give you, so you have to calculate how many electrons there are in the bonding orbitals, which is, to make things simple, remember that every time you have the bonding and anti-bonding full, this will contribute to 0, so you don't need to include them. So how many electrons are in the bonding? There are 6, right? 2 in here and 2 in here, and 2 in the anti-bonding divided by 2, that's the formula. I have a bond order of 2. Now, what happens if you add one electron? If you add one electron, the bond order for O2 negative, you add 1 here. Now suddenly you have 6 minus 3 divided by 2, this is 1.5. And if you add yet another electron, the bond order for oxygen 2 negative shall be 6 minus 4 divided by 2 is 1. So as you see, the bond order decreases as you add electrons in the anti-bonding. That's important. If you were to add electrons in the bonding, the bond order would increase. So there you go. You got that this bond order is 2, this bond order is 1.5, the bond order for this substance is 1. So how can we relate that? If you think about it, the higher the bond order, the higher will be the bond strength. The bond strength. Because there's more electrons being shared, that will make the bond more fruitful, if you will, stronger. And that will shorten the bond. It will make the bond length shorter. And now what does that mean in terms of frequency of vibration? If you remember, in terms of frequency, I don't know if you're familiar with this, divided by the mass, this is the strength of the bond, this is the mass of the bond. If you've never seen this equation before, may as well ignore it, but what the take-home message is that as long as this trend follows, the higher the frequency of vibration will be. Because the strength, this is the constant of the spring that makes the bond vibrate. Therefore, following this trend, the stronger the bond, the shorter the bond, and the higher the frequency. And therefore, you can say that this substance has a stronger bond, stronger and shorter bond because it has a higher bond order and because it has a higher frequency of vibration, and this one will have a weaker bond because it has a lower bond order, weaker bond. Therefore, if it has a weaker bond, it will have a lower frequency of vibration. Just a technical note, these are wave numbers, not frequency. If you remember from our first semester, the speed of light relates the wavelength with the frequency. The wavelength is the inverse of your wave number. Therefore, you can just plug this in here. Because C is a constant, the wave number is directly proportional with the frequency. So I've been talking about frequency because it's actually what you can calculate with this equation. Again, if you have not seen this equation, do not pay too much attention, focus mostly on the qualitative description. But if you were wondering what's the relationship between wave number and frequency, this is it. They are directly proportional.